Welcome to our review for Finite Math, Exam 1. Let's go ahead and get started. So first we have a couple of functions that are given to us here. F of x is x squared minus 3x plus 1, and g of x is 5. So g is a constant function. There's no place to input x, so whatever the x value is in here, the output is always 5. So first off, in part A, they want us to evaluate g at the square root of 3. Well, again, since there's no place to plug that x in, g of square root of 3 is just going to be 5. Okay, so there's no x to plug in here. Next, they want us to evaluate f at negative 2. So here, what I like to do is rewrite the function, and in place of the x, put empty parentheses. So I'm going to do parentheses squared minus 3 times parentheses plus 1. And in those parentheses is going to go my negative 2. So negative 2 squared and minus 3 times negative 2 plus 1. So negative 2 squared, that's 4. And now this is negative 3 times negative 2, positive 6, and plus 1 on the end. So 4, 6, and 1 gives 11. And then in the last one, we've got f plug in a minus 3. So this is a composition. So again, rewrite your function with empty parentheses in place of the x. So this is going to be parentheses squared minus 3 times parentheses plus 1. So the x is what was going in the parentheses, and our x here is a minus 3. So that whole quantity goes inside the parentheses. So this is a minus 3 squared minus 3 times a minus 3 plus 1. And now here we can FOIL this out. Remember, that means a minus 3 times a minus 3. So our first terms here would give us a times a squared. And then the outer terms, negative 3a. Inner terms, another negative 3a. That's negative 6a. And then our last terms, negative 3 times negative 3, positive 9. Let's go ahead and change this to add the opposite of 3. That negative 3 is going to distribute in times each piece. So negative 3 times a minus 3a. Negative 3 times negative 3 plus 9. And then plus 1 on the end. So now we just collect all our like terms. A squared is the only squared term. Negative 6a and negative 3a give us a negative 9a. And then 9 and 9 is 18, and another one is 19. And then we've got the simplified form for f plug in a plus 3. So notice that we still have an equation in a. We don't have a number output because we didn't have just a number as an input. So you should expect, if you've got variables as an input in a function, that you're going to get an equation in that variable. Alright, up next we're working with supply and demand functions. So P equals S of Q is 3Q. That's our supply function. S, remember, stands for supply. P equals demand at quantity Q, or D of Q, is 50 minus 4Q. That's our demand function. So those are our supply and demand functions for a certain product that's manufactured. First of all, we want to graph these equations on the same set of axes. So remember that the supply and demand functions are going to be intersecting lines. So let's start with the supply function here. So that's P equals 3Q. And here, here I've given you a grid with x and y axis, and if we look here, our q is acting like our x and our p is acting like y. So this is p here, and then q is down here. And that p equals 3q, you can think of as 3q plus 0. So this is now in y equals mx plus b form. So if you want to graph that, you start from your y-intercept, which is 0 down here, and then your slope gives you rise and run. So our slope is 3, or 3 over 1, so we would rise 3 and run 1. Alright, well, let's look at the other function before we go ahead and graph this one to kind of get an idea of what we want to use for our scaling along the y-axis and the x-axis. So P equals 50 minus 4Q, that's our demand equation. And I'm going to switch these two around and write it as P equals negative 4Q plus 50. So I'm going to start with 50, and then my slope is going to be fall 4, run 1. So this one starts at 50 and it falls, this one starts at 0 and it rises, so the highest that these guys are going to go is up to 50. So why don't I label this off where in tens, my y-axis here, 10, 20, 30, 40, and 50. So I'll scale it in 5s. And then your x-axis doesn't have to have equal scaling, but I think we're okay to do equal scaling here. So if we do 10 and 20 and 30 and 40, I believe is all we're going to need. So first let's start here. So y-intercept is 0, rise 3, run 1. So we're going to start at 0. And rise 3, run 1 would be the same as rising 1, 2, 3 groups of 10 and running 1 group of 10, which puts us right here. So as long as you have equal scaling on the axis, we rise 3 10s and run 1 10. And if we draw that line in there, that looks something like this. So that's our supply function. We'll label that S. Our demand function, we're starting at 50, so up here at 50. And we are going to fall 4, run 1. So we're going to fall 1, 2, 3, 4 groups of 10 and run 1 group of 10. And now we draw the line through those 2 points. So that'll look something like this. And then our intersection point right there, remember that is your equilibrium price and quantity. So that looks like that's, somewhere around the quantity or the x value is 7.5 and the y value looks, pretty close to 20. Okay, but remember graphing is not the most accurate way to get that equilibrium price and quantity. Algebraically is the best way to do that. So remember what we do to find the equilibrium quantity and price for this is we solve the system of equations. So we've got P equals 3Q, and then we've also got P equals 50 minus 4Q. Okay, well P is equal to both of these expressions, so these two expressions have to equal each other. Or think of taking this 3Q and plugging it in for that P. So we get 3Q equals 50 minus 4Q. So this is now a linear equation, and remember what you want to do with linear equations, get your variables on the left, numbers on the right. So we want to add 4Q to both sides, on the right and on the left. And these add off to 0, so they cancel. 3Q and 4Q here is 7Q. Equals, all that's left on the right hand side is at 50. And now to solve for Q, we divide off the 7 on both sides. Undo the multiplication. So 7 divided by 7, those divide off to 1, and we get Q equals 57. And you can write that as a decimal too if you want. I'm going to leave it as a fraction for the time being though. And now to get our price, so there's our equilibrium quantity, our equilibrium price, plug in back into either original equation. The easier one to plug into is the first one. So P equals 3 times Q is going to be 3 times that 57th, which is 157th. Or if you want, since P is our price here, we can write this in dollars and cents, and if you do that division on your calculator, round to the nearest penny, 21.43. And the notation that we used in our books, I believe, was Q star and P star here. Okay, so those are our equilibrium price and quantity. 21.43 for our price and 57 fractional quantity. All right, we're doing some more work with lines and equations of lines in problem number 3. So we want to find the slope and the y-intercept of this line 2x minus 3y equals 10. So remember that the way you find that is you solve that equation for y. So over here, let's go ahead and solve this equation for y. So I want to keep that negative 3y on the right-hand side, or I'm sorry, on the left-hand side. Subtract 2x on both sides to bring that 2x over. So the 2x and negative 2x add to 0. I am left with negative 3y equals 10 minus 2x. And now to undo that multiplication, I divide by negative 3 on both sides. So these negative 3's, they cancel, they divide off to 0. Y equals 10 divided by negative 3 is negative 10/3. And then if you want, again, this is plus negative 2x. You can always change the subtraction to add the opposite. Negative divided by negative is going to be positive, so this is plus 2/3 x. Remember that 2x over 3 would be the same as 2/3 x because that x is on the top. So now if we do a little bit of rearranging, this is 2/3 x minus 10/3. Okay, positive 2/3, negative 10/3, same thing we had up here. So now our slope is going to be 2/3, the coefficient of the x, and the y-intercept is negative 10/3, and that is C here. It said your slope and y-intercept, so that would be respectively 2/3 and negative 10/3, and all of the rest of those are off. Number 4, the equation of the line through the 2 points, 2, -1, and 1, 3 is. So let's label these points, x1 and y1, and x2 and y2. So remember, the first thing that we need to do there is find our slope. So our slope's going to be y2 minus y1. So that's going to be 3 minus negative 1 over x2 minus x1. So that's going to be 1 minus 2. So 3 minus negative 1 is 4. 1 minus 2 is negative 1. 4 divided by negative 1 is negative 4. This is a line with slope 4. I'm sorry, negative 4. And remember that the slope is the coefficient of x. So here I see a negative 4 as my coefficient of x. And here I see a positive 4, so that one's out. Here I see a negative 4. And here I see a positive 4, so that one's out. So it's either these A or C, or it's none of those. Okay, well, this one is in point-slope form, and this one is in slope-intercept form. So remember, point-slope form is y minus y1 equals m times x minus x1. And so let's look at this one first. So we've got the slope, negative 4, is in there. Y minus 1, okay, well, let's see. That would be my y1. That would be a y-coordinate. And I don't have 1 as a y-coordinate of either of those points. If it was y minus negative 1, then this would be a plus. Now, x minus 3, that would be the x minus x1. So that means you have to have 3 as an x-coordinate. 3 is not an x-coordinate of either one of those points. So this guy is out. So it's either got to be this one, or it's none of these. So let's do the plug-ins here. Why don't we use the 0.13, since it'll be a little bit easier, it'll have no negatives in there. So y minus, and our y value is 3, equals m was -4, times x minus our x value, which here is 1. Now we could have used this point here. We could have done y minus -1 and -4 x minus 2. Once you simplify, you'll get the same answer. So it doesn't matter which point you take there. So now we want to take this -4 and multiply in times each piece. So we'll have y minus 3. Let me do this. Let me move this guy out of the way a little bit for us here. Since I actually have the ability to do that. Alright, so -4 comes in here, -4x, and then -4 times -1, +4. So we've got y minus 3 equals -4x plus 4. We want to solve for y to see if it matches part C. So +3 on both sides. And when we add those up, these guys cancel. They add to 0. 4 and 3 here is 7. So this is going to be y equals -4x plus 7, which is part C. Okay, next up we're making some M&Ms. Good healthy food. So 1,000 bags of M&Ms cost $130 to make, and the cost of 3,000 bags of M&Ms, you could put those down on a weekend, right? Late night movie, is $350. Find a linear cost function. So I'm telling you it's a linear cost function, so right away we know that our cost here, c of x, is mx plus b. So we just need to find the slope and the y-intercept. And remember the way that you do that, you start off, you need an x value and a y value, a couple of them, and your y value is your c of x, your cost. So 1,000 bags cost $130. So the 1,000 is the independent variable because the cost depends on the number of bags. So 1,000 is x there, and the cost of 1,000 is $130. And then 3,000 bags cost $350. So again, 3,000 is your independent, and they cost $350. So now, once you've done that, you've got, this is x1 and y1, and x2 and y2. So you've got 2 points. So once you've got 2 points, then you can find the slope. Slope is y2 minus y1 over x2 minus x1. So you're always going to start off like that. You've got to get a table. You've got to get 2 x values and 2 y values. So y2 minus y1 up on top, 350 minus 130. And then down on the bottom, x2 minus x1 here, 3,000 minus 1,000. So 350 minus 130 is 220. And then 3,000 minus 1,000 is 2,000. And then if you divide this out as a decimal, it's 0.11. So now we can take that 0.11, we can plug it in here for slope. Okay, so what we know now is, if I rewrite here with y equals mx plus b. And what we know is that our m is 0.11. So y equals 0.11x plus b. Now we just need that b. We need that y-intercept. So remember, we can take either one of these original ordered pairs and plug into the expression to get that b. So why don't we use the first one? The numbers are a little bit smaller, be a little bit easier. So our y value is 130 when our x is 1,000. So plug 130 in here for y equals 0.11, and our x here is 1,000 plus b, and so we get 130 equals, multiplied by 1,000, just going to move the decimal 3 places over, so this will be 110 plus b, and now subtract 110 on both sides. Undo that multiplication. So that leaves us with a 20 on the left, and these guys add to 0, and we are b left on the right all by itself. So b equals 20. So now we can plug that in here. So now we get y equals 0.11x plus 20. So that's part A. That's our cost function. So this is our c of x. Y equals c of x is 0.11x plus 20. Now they ask us, how many bags can we produce for $250? Okay, so that 250, that is a y value. That's a c of x. That's a cost. Okay, so they're saying plug in that 250 for y, solve for your x. So plug 250 in for y right here, and set that equal to 0.11x plus 20. And now solve for x. So subtract 20 off on both sides. So you get 230 on the left, and these add to 0, they cancel, equals 0.11x. And let me bring that over here. So 230 equals 0.11x, and now we want to divide off that 0.11 on both sides. And these divide to 1 to cancel. X equals 230 divided by 0.11. If you do the calculator work there, you get 2090.91. And that's an x value. Okay, those are quantity. Okay, number of bags of M&Ms. So here we can go ahead and we can round. Well, actually here, how many bags can we produce for $250? We can produce 2,090 bags. We can't produce 2,091, okay, because it's 2,090.9. So in practical terms, we would have to round down. Okay, so our x is we can produce 2,090 whole bags of M&Ms. Okay, we can't produce that last bag. Not enough money. So there's the answer to part B. And here was our answer for part A. So same thing that we did up here when we had the 2 points. First found the slope, and then here we used point slope, but here we plugged into mx plus b. And you can do either way. Okay, number 6, we are still looking at a cost function. Here we are making some party favors. Going to make some noise here, have a little bit of fun. The cost of x is the number of party favors is 0.03x plus 150. And they can be sold for 25 cents each. Find the break-even point. Okay, so the break-even point, remember, is when the revenue equals the cost. So it's when the revenue from an input of x equals the cost from an input of x. Okay, well, we don't have the revenue function here. Okay, got the cost function, but our revenue is 25 cents each. So remember that we have to take our revenue function, r of x here, is going to be the price that we can do times the quantity. And the price we know is 25 cents each. And then our quantity for us, it's x. X is our quantity. So that's 0.25x. And then we know that our cost, c of x, is equal to 0.03x plus 150. And then break even is when revenue equals cost. So we're working on part A here. So we set these equal. So similar to what we did when we did equilibrium price and quantity. So 0.25x has got to equal 0.03x plus that 150. And we want to solve for x. We want to get the x terms on the left. So subtract 0.03x on both sides. And 0.25 minus 0.03 is 0.22x. These add off to 0, so they cancel, equals 150. And now x is multiplied by 0.22. We want to divide that 0.22 off on both sides. And what's left is x equals 150 divided by 0.22, and if you do the calculator work there, you get 681.81. And so the break-even point would be, well, I guess here we're going to just have to round to the nearest. So break even, you're going to break even just after, between the 681st and the 682nd. Okay, so even though this is a fractional input, you can leave it like that, or you can round it to 682. Either way is fine. So here, it's not like up here we didn't have enough to produce that extra bag of M&Ms. Not quite the same thing here. Okay, this is, you actually have to be at 0.8 units, 681.8, to be actually at the break-even. And then in part B, they want us to find the profit from a sale of 700 party favors. So 682 was our break-even, so after 682, we're going to have profit. So remember that profit here, the profit function, the profit from x units is the revenue, what you get, R of x, minus what it cost you, C of x. So our revenue was the 0.25x minus our cost here, that was the 0.03x plus 150. So if you do the subtraction here, 0.25, if you distribute the minus sign, this will be minus 0.3 and minus 150. So that's going to give us 0.22x and then minus 150. So then the profit from 700 is going to be plug in 700 in for x right here. So that's going to be 0.22 times that 700 and then minus 150. So this is the profit function, 0.22x minus 150, and then this is the profit from 700. And if you do the plugins here, 0.22 times 700 minus 150, you actually get 4. So that's going to be a profit of $4. Hoo-hoo, let's go throw a party, right? Got $4 worth of party favors. $4 worth of profit. Alright, next up in number 7 here, we're given a relationship between the pay per hour and the number of units per hour that workers put out. So it says a study in relationship between productivity and wage is conducted and following information is found. So that's this information. Fill in the table below, use it to find the least squares line. So that's the regression line. So those equations you will be given, and those are the following. Your slope for the regression line, mx plus b, is going to be the equation of the regression line. So remember that this guy here is y hat, because it's an estimating line, equals mx plus b. And your M is N, which is the number of data points, times the sum of X times Y, so the X value times the Y value, minus the sum of X times the sum of the Y's, and then that is divided by N times the sum of X squared minus the sum of the X's quantity squared. And then your B is N, sum of the Y minus M, sum of the X's over N. So those you'll be given. So we have to fill in this table here to find these quantities, the sum of xy, sum of x, and sum of y, sum of the x squares. So you have an x column, a y column, you'll need an x times y column, so you'll multiply straight across. You need an x squared column and a y squared column. So the number of units per hour depends on the pay. As the pay increases, the workers manufacture more units per hour. They've got more incentive to do so. So pay is our x and units are our y. So the x values are going to be 450, 6, 750 or 7.5, 8, and 10. And then this last row down here is going to be our total row. Let me go ahead and separate that. So down here is our total, which is the sum. Y values here, parts per hour, 25, 30, 33, 39, and 42. So that's these values here. So I just transfer those over to the table. To get the XY column, you multiply straight across. So you can do these on the calculator, that's fine. 4.5 times 25, that'll give you 112.5. 6 times 30 is 180. And so on. So you'll get 247.5. and 312 and 420. The x squared column, take these x values and you square them. So 4.5 squared, 4.5 times 4.5 is 20.25. Again, this is calculator work. 6 squared is 36. 7.5 squared, 56.25. 8 squared, 64, and 10 squared, 100. And then the y squared column, take the y values and square those. So 25 squared is 625. 30 squared, 900. 33 squared will give you 1089. 39 squared, 1521. And then 42 squared, 1764. Okay, then we total these columns here. So total those on the calculator. Your first column total is 36. Second one, 169. The third one, 1272. The sum of the x squared column, 276.5. And then the sum of the y squared column, 58.99. Now, if you have a calculator that has stat mode, then you can confirm these entries that are in the table. So I'm going to demonstrate with the TI-84 Plus. So here we go into stat mode, and then we go to edit, and now we want to enter our x values in as list 1 and our y values as list 2. So here I want 4.5, enter, and then 6, enter, 7.5, 8, and 10. Once you got those, you arrow to the right until you're in list 2, and then 25, enter, 30, 33, 39, and 42. Once we've got those in, we press the stat button again. Now we arrow to the right, so we're under calc. We're using 2 variables, so go down to 2 variable stats, press enter. You may not get this screen depending on what version of the calculator and what operating system you're using. If you do, you should just be able to press enter and go on through the screen to the calculate. So now we see sum of x's here, 36, right there. Sum of the x column. Sum of the x squared, 276.5, right here. Sum of the x squared column. Arrow down. Sum of the y's, 169. So here's our y column. Sum is 169. Sum of the y squares here, 5899. Y squared. Sum is 5899. Arrow down again. Sum of the xy's right here, 1272. XY column sums up to 1272. So this total row is giving you the sum in the formula, the sigma. Okay, so here, sigma xy is this number, 1272. Sigma x is 36. Okay, so this is sigma x, sigma y, sigma xy, sigma x squared, and sigma y squared. So now we can plug in and compute our slope and our y-intercept. So remember, n is 5. That's our number of points. Let's see, sum of the xy's, that's the 1272. Minus sum of x, sum of y, so that's 36 times 169. And we are dividing by n, 5, times the sum of the x squares, so that is the 276.5, minus the sum of x quantity squared, so that's the 36, and it gets squared. And we can enter this into the calculator. Let's do that. So let's clear this out. Come over here. So we want to put that numerator in parentheses. So 5 times 1272, and then minus 36 times 169. So we only need parentheses to separate the top from the bottom. We don't need extra parentheses around the 36 and the 169 individually because the calculator's got order of operations. So it'll remember that. And then on the bottom, we've got 5 times 276.5 minus 36, and hit the x squared button and close our parentheses. And again, the calculator will remember to square and multiply before you do this subtraction. But because of order of operations, we're actually, when we do the fraction here, we're taking the whole numerator and dividing by the whole denominator. And if we didn't enter in those parentheses, then the calculator would follow order of operations, and the order of operations would do things in the wrong order. It wouldn't do whole top divide by whole bottom. Okay, so that gives us 3.19075. So let's keep some extra decimal places in that slope. And now we're ready to find y-intercept. So your y-intercept, sum of the y's, which is at 169, minus m, our 3.19075, times the sum of the x's, which was our 36, and then divide by n is 5. Let's go ahead and key this in. So I'll need parentheses for the numerator. 169 minus 3.19075 times 36. And close our parentheses, divided by 5. 10.83 if we round it. So now we've got our slope here and our y-intercept. So now we can state the formula for the estimation line, the least squares line. So y hat is mx plus b. We know m is 3.19 times x, and then our b 10.83. So there's our least squares line. And now it says, then estimate the number of units if the wage were 12. So that's saying, what if x equals 12? What is our y hat value? So then we just plug in x equals 12. So 3.19 times 12, plug it in here, plus 10.83. And we can compute that real quick. 3.19 times 12 plus 10.83. 49.11. So it's approximately 49 units per hour. Because remember, our y value is units per hour, number of units per hour. Now, one thing that's related to the least squares line that I haven't asked here is the coefficient of correlation, r. So if I asked that, you would be given the formula for it. And remember that if r is approximately equal to 1, then that means that we have a strong positive linear relationship. So it tells how close these points here would be, these points, to actually being on the regression line. And remember, if r is approximately -1, then you've got a strong negative linear relationship. So positive means it would slope up from left to right, negative it would go down from left to right. And if r is approximately 0, then there's no linear relationship. Could be some other kind of relationship, but no linear relationship. So remember here, approximately 1 would be, well, 0.85, 0.9, 0.95. Those are nice, strong linear relationships. And on the negative side down here, negative 0.85, negative 0.9, negative 0.95. Here r is approximately 0, so 0.1, negative 0.2. Those are pretty close to 0. Not really a lot of relationship. Right, next up we're solving a system of equations. Here they ask us solve the system 2x plus y minus z is 8, y plus 2z is -1, and 4x minus 3z equals 15. Show the first pivot to the right. So I'm asking you to show the first pivot, and then down here is marking the final answer. So, well, let's do a little bit of rearranging here. Well, let's line up our terms here. So this is 2x plus y minus z equals 8. And then we've got y plus 2z equals -1. And then we've got a 4x minus 3z is equal to 15. So remember, what we want to do is we want to put it in echelon form. So we want to get it, we want to eliminate this x term here first. So we want to we'll use the 2x as our pivot term, and we'll clear out that first column. Well, this entry's gone, so I made this a little bit easier for you. And so we need to eliminate that 4x right there. So remember, what we do is we want to write our instruction for our row operations that we're using here. So if I multiply this first equation by -2, then I'd have -4x. If I add it to that 4x, then it'll cancel out. So I want to do -2 row 1 and add it to row 3. And that's going to replace and give my new row 3. So now let's actually carry that out. So if I did the -2 here times the first equation, -2 times 2x would be -4x. -2 times y minus 2y. -2 times -z, positive 2z. And then -2 times 8 would be -16. Then we're adding that third equation right here. So 4x minus 3z equals 15. And if we add those, the x terms cancel out. We get a -2y, positive 2z, -z, being -z here. -16, positive 15, -1. And then to simplify things, we could multiply through by a -1, but let's just go ahead and leave it. So remember, we're just replacing the third equation. The first and second equations stay the same. So first equation is 2x plus y minus z equals 8. Second equation stays the same, y plus 2z. So y plus 2z equals -1. And now our new third equation here. So -2y minus z is -1. So now our pivot is the y here. And we want to use that y to cancel out this -2y. So remember, this is 1y. And so the 1 is our pivot. And so if we multiplied the second equation by 2, then we'd have 2y. Add that to the -2y, they would cancel out. So our next instruction here, we are going to take that second equation, 2 times row 2, add that to row 3, and that's going to replace row 3. So 2 times that y is going to be 2y. 2 times 2z is going to be 4z. And then 2 times -1 is -2. Third equation, we're keeping the same. -2y minus z is -1. And then we add those up. The y terms cancel out. 4z minus z is 3z. And -2 and -1 is -3. So now our system of equations, only the third equation changes. First two stay the same. So 2x plus y minus z equals 8. And y plus 2z is -1. Those two stay. And now 3z equals -3. Okay, so now we've cleared out that second column. We are in echelon form here. You can see it right here. So you can see that triangle, that triangular or echelon form. So now in the problem, the only work I asked you to show was show the first pivot, and the first pivot would have ended here after we rewrote, because this is our first pivot here. We cleared out that first column. So you would have been done there for the work you'd needed to show on the test, but you'd need to do this extra step to find your solution anyways. So in any case, down on this third equation now, we've got 3z equals negative 3, so we can divide both sides by 3 there and get z is equal to negative 3 divided by 3, negative 1. So we know z is negative 1. So actually we can look over these choices here, and z is negative 1, so this choice is out. And here z is 3, so that's out. Here z is negative 1, that's a possibility. Here z is 1, that's out. And here that's no solution. That should be out also. It should be C. Okay, let's confirm that. Let's go ahead and do our back substituting. So remember, what you do is you want to take that z is negative 1 and you want to plug it back in the second equation. So that's y plus 2z, which is going to equal y plus 2 times negative 1. And that's got to equal negative 1. So I plug my negative 1 in here. Equals negative 1. So this is negative 2. To get y minus 2 is negative 1. Add 2 on both sides. So these guys cancel out. Y equals negative 1 plus 2, positive 1. And y is a 1 there. Remember, this is x, y, z. So far so good. And now we've got our y is 1 and we've got our z is negative 1. Plug those back in the first equation here. So that's going to be 2 times x, and our x is what we're solving for, plus y, which is 1, so plus 1, minus z, and our z is negative 1, so it's going to be minus negative 1, equals, on the right hand side, 8. Here double negative makes a positive, so this is going to give us 2x plus 2. So 2x plus 2 equals 8. And then subtract 2 on both sides, so minus 2 minus 2. These guys cancel. 2x is equal to 8 minus 2, 6. And so divide both sides by 2. So 2x equals 6. Divide by 2. And x equals 3. And that's what we've got here, x equals 3. So indeed it is C. Number 9 is an application problem. So it says set up the following. Okay, and just equations don't solve. Okay, so we're just setting up. So we're going to write equations and show how we get them. So we own a shipping firm. We're handling the shipment of big screen TVs from 2 warehouses to 3 retail locations. So this is a shipping problem. So we're actually going to have 6 variables in this problem because we've got 2 possibilities for where these TVs can come from and 3 possibilities for where they can go to. So let's start setting up a table here. And we've got 2 warehouses, warehouse number 1 and warehouse number 2. So this is our from. It can be from warehouse number 1 or from warehouse number 2. And they can go to either, let's see, Los Angeles, New York, or Houston. So LA, New York, or Houston. And let's let our variables, let's let U be the amount that goes from warehouse number 1 to LA. V is going to be the number that go from warehouse 1 to New York. W will be warehouse 1 to Houston. X is going to be warehouse 2 to LA. Y is going to be warehouse 2 to New York. And Z will be warehouse 2 to Houston. Now let's do totals. on the rows. So row totals here, and then column totals down here. So warehouse number 1 can supply 24. So number 1, its total, all of these 3, have to be 24. Because this is what is going from warehouse number 1. So that's its supply. Number 2 can supply 40. So this is from number 2. These 3 have to add up to 40. And then LA needs 30. Okay. These two values, U and X, those are going to LA. So this is the 30. New York needs 20. So New York, that's this column, 20. V and Y are the numbers that go to New York from number 1 to number 2. And then Houston needs 14. And that's W plus Z. From number 1 to Houston, from number 2 to Houston. And so if you add these vertically here, we get 64. And if you add these horizontally, we also get the 64. So then what are our equations? Well, across the rows and down the columns. So we get U plus V plus W is equal to 24. Okay, that's the supply from number 1. X plus Y plus Z is equal to 40. That's the supply from number 2. To LA, that restriction is going to be U plus X equals 30. To New York, that's going to be V plus Y equals 20, because they need 20. What's going to Houston, W plus Z, is going to equal 14. So you've got 5 equations. Just getting those from the rows and the columns in this table. So this is the showing how is just the table, and then these are the equations. Okay, and we're done with that one. We don't need to solve this 5 equations in 6 variables. Aren't you glad? Alright, and then our last problem here, we're using Gauss-Jordan. So in other words, we're using matrices to solve the following system. So let's convert this to matrix form here. So our coefficients, this is a 1x here, and this is a negative 1z. So we set up our initial matrix, and we're going to have an x column, a y column, a z column, and our right-hand side. In this first equation, we've got 1x, negative 2y, and 1z. So 1 in the x, negative 2 in the y, 1 in the z, and our right-hand side, negative 2. Second row, 2x, no y term, 3z. So 2 in the x, 0y, 3z, right-hand side is 1. Last equation, there's no x term, negative 4y, negative 1z. So no x term, negative 4y, negative 1z. And then our right-hand side is negative 5. Alright, so remember what our goal is here. We want to get this into triangular form or echelon form. We want to clear out this column. Well, this is already 0, but we want to clear out that 2. We want to clear out this negative 4. And so we've got a 1 up here in that first equation, that first row. And so we're going to use that as our pivot. Won't have to do any switching rows around because we've already got a 1 in that upper left-hand corner. We want to use that 1 to cancel out the 2, and then this is already gone. So we just have to clear out that first column. So we're going to do 1 row operation on each line here. So I am going to multiply this first row by negative 2. That'll make that a negative 2. That'll cancel out the positive 2 when I add them. So I want to do negative 2 times that first row and add it to the second row. and that's going to replace our second row. So let's go ahead and do that. So negative 2 times 1, negative 2, negative 2 times negative 2, positive 4, negative 2 times 1, negative 2, and negative 2 times negative 2, positive 4. Okay, now we just rewrite the second row. 2, 0, 3, 1. 2, 0, 3, 1. Now add these vertically. 0, 4, 1, and 4 and 1 is 5. So our new matrix, only row 2 gets replaced. Row 1 and 3 stay the same. So row 1 is still 1, negative 2, 1, negative 2. Row 3 down here is still 0, negative 4, negative 1, negative 5. And then row 2 is right here. It's our new row 2. So 0, 4, 1, and 5. Okay, now this is cleared out. Okay, so that first column is all clear. So now we go to the second row, second column. That's this position. And we've either got a positive 4 or a negative 4 to use as our pivot. Might as well use the positive 4. And in fact, if I just add the second row to the third row, they'll cancel out. Those 4 and negative 4 will cancel out. So what I want to do here is I just want to do row 2, add that to row 3. Whoops, I said row 2 and I wrote row 3. Row 2, add to row 3, and that is going to replace row 3. So here's row 2, 0, 4, 1, 5. And then underneath it, row 3, 0, negative 4, negative 1, negative 5. And I add these up vertically, 0, 4 minus 4, 0, 1 minus 1, 0, and 5 minus 5, 0. Uh-oh, we got a 0 row. So when we rewrite here, I've got 1, negative 2, 1, negative 2. And then that second row, 0, 4, 1, 5. And third row is all zeros. So remember what that means. That means that we're going to have infinitely many solutions. We're going to have a parameter in our solution. And there's a couple ways we can proceed from here. We can change back to equations at this point. And then we'd have to write x in terms of, remember z is going to be your parameter, x in terms of z, and then also write y in terms of z. Or we can use this 4, and we can clear out the negative 2 right there, and then change back to equations. And that'll actually be a little bit easier. So instead of going for triangle form, we're going to finish clearing out that second column. So I want to use a 4 to cancel out a negative 2. So if I multiply this first equation by 2, then I'd have 2 times 2, negative 4. Add the second equation. Those are going to cancel out. So here's what I'm going to do. This is still my pivot, so you start with your pivot row. So we're doing row 2. And then we are adding that to row 1. And we're replacing row 1. You always replace the row that you're adding to, not the pivot row. Alright, so rewrite your row 2, 0, 4, 1, 5. And then 2 row 1, 2 times 1, 2. 2 times negative 2, negative 4. 2 times 1, 2. And 2 times negative 2, negative 4. Now add these. 2, 0, 3, and 5 minus 4, 1. So that's our new row 1. So in our next step here, we've got 2, 0, 3, 1 is our new row 1. And row 2 and row 3 stay the same. So row 2, 0, 4, 1, 5, and row 3, 0, 0, 0, 0. Okay, now let's go ahead and reduce these first entries in the row down to ones. And then this is going to mean that when we switch back over to equations, that our job's going to be a lot easier. So what I'm going to do in my next step here is I am going to divide the first row by 2. So I'm going to do 1/2 row 1 is going to replace row 1. So divide everything by 2. And then I want this 4 to be a 1 also. So I'll do 1/4 times row 2, replace row 2. So I'm dividing everything by 4. So divide row 1 by 2. So 2 divided by 2 is going to be 1. So here I'm doing 1/2 times that row. And then here I'm doing 1/4 times that row. So 1/2 times 2, 1. 1/2 times 0 is 0. 1/2 times 3, 3/2. And then 1/2 times 1, 1/2. 1/4 times 0, 0. 1/4 times 4, 1. 1/4 times 1, 1/4. And 1/4 times 5, 5/4. And then we've got that 0 row. Okay, now we've simplified it as much as possible in matrix form, so if we change it back to equations, we'll have a lot less work to do. So now if we go back to equations, remember this is the x column, the y column, the z column, and then your right-hand side. So we're going to have 1x, no y term, and 3/2 z. So this will be x plus 3/2 z equals, right-hand side is 1/2. And then here, 1y, 1/4 z equals 5/4. So this will be y plus 1/4 z equals 5/4. And then this last row, you could just translate that as z equals z. And because this is just saying 0x plus 0y plus 0z equals 0. Well, that happens for any value of x, y, and z. So this down here just means that the last equation is always true for any values of z. So now what do? Well, we want to write the x and the y in terms of z. So we want this to come over on the right as a negative, and we want this term to come over on the right as a negative. So this is going to give us x equals 1/2 minus 3/2 z, if we bring that over as a negative. And then second equation becomes y equals 5/4 over on the right. And then 1/4 z comes over as a negative, 1 minus 1/4 z. And then this last equation, that z equals z, that just means that z equals any number. That's your parameter, remember. And then usually we would write that solution as an ordered triple. So your x coordinate here is 1/2 right here, 1/2 minus 3/2 z. And your y coordinate is right here, 5/4 minus 1/4 z. And then your z coordinate, you just leave that as z. That's your parameter. And then comma z equals any real number. So any number, or sometimes people will write z as an element of minus infinity to infinity if you use interval notation, or z is between negative infinity and infinity. So what that means then, remember, is you can pick z to be any number. You plug it in all the way across, you'll get an x and a y and a z. So for each value of z, you get a different solution. So that's your infinitely many solutions. So for example, if, and this is the final answer here, But if I ask you, okay, well, find two different solutions, well, you could just pick values of z. So for example, if z equals 0, then that'll give you 1/2 minus 3/2 times 0. So that'll just be 1/2. And then 5/4 minus 1/4 times 0, well, that'll just be 0, so 5/4. And then the z value that we picked that to be 0. So that's one solution, 1/2 5/4 0. If we picked z equals 1 instead, then that will give us a different solution. That'll give us 1/2 minus 3/2 times 1, so 1/2 minus 3/2. And here 5/4 minus 1/4 times 1, so that'd be 5/4 minus 1/4. And then the z that we picked was 1. So that is 1/2 minus 3/2, so that's going to be 0.5 minus 1.5, so that's -1. And then 5/4 minus 1/4, that's 4/4, which is just 1. And then we picked z to be equal to 1. So -1, 1, 1, there's another solution. And any value for z that you pick and plug in all the way across, you get a different solution. Okay, so this one ended up being a little bit more work than the previous example that we did up here that actually had 3 numerical answers for x, y, and z. Okay, if we didn't get that 0 row, then we could have just gone for triangular form like we did here, and then changed back to equations and then plugged back in. So back substitute. Plug z back in, and then plug y and z back in to get your x. So this is actually the tougher of 2 types of problems that I could give you. I could give you a problem where you have numbers for x, y, and z, so you get a numerical answer for each one. That's what happens when you don't get the 0 row. Then you just go for triangular form. Or if you get a 0 row, then that means that you have a parameter in your solution. You've got infinitely many solutions. Then you solve for x in terms of z and y in terms of z.